So today we are starting with a chapter called aldehyde ketone carboxylic acid, and today we are starting with a topic called carboxylic acid. Being a small topic, we'll be able to finish before we go off for the summer vacation. You know, carboxylic acid, they have a general formula RCOH. You can expand it if you wish, or C double bond OH, and we have a suffix for naming of carboxylic acid. The suffix we are going to use is called oic acid. We are going to use the suffix called oic acid. So let us see a few common names and the IUPAC name. So let us see some members with their common name and the IUPAC name. You're going to see the members with the common name and the IUPAC name. The first member that we have is HCOH with 1 carbon. Second member with 2 carbon, we have CH3COH. Third member with 3 carbon, we have CH3CH2COH. The one with the 4 carbon, then we have got the one with the 5 carbon. We can condense it if you wish. We can have the straight chain with the 6 carbon. Okay, we'll take it later. First of all, let's handle all this. 1 carbon common name you know is called formic acid. That in your 10th class. 2 carbon acid is commonly called acetic acid. 3 carbon acid commonly called as propionic acid. 4 carbon, the common name is butyric acid. And the 5 carbon carboxylic acid is called valeric acid. With regard to the IUPAC name, you know, 1 carbon one is called methanoic acid. So simple, oic acid we have to use. 2 carbon it's called ethanoic acid. 3 carbon one is called propanoic acid. The 4 carbon one is called butanoic acid. The 5 carbon one is called pentanoic acid. This is as far as the IUPAC name goes. Now let us see a few more members. We'll see some of the aromatic compound also, like for example benzoic acid and so on. So we have got the one with the 5 carbon, one with the 6 carbon. This is commonly called as nothing but caproic acid. Common name is caproic acid. IUPAC name will be hexanoic acid, as simple as that. Let us take the benzene aromatic carboxylic acid, like we have got benzoic acid. Whenever COH group is directly attached to the ring in IUPAC name, for COH group we use carboxylic acid. So we write on the name of the ring, that is benzene, and we use the word carboxylic acid. So IUPAC name will be benzene carboxylic acid. We can have 2 COH groups, like we have a COH over here, COH over here, 1-2 position. Commonly it is called phthalic acid. That's a common name, phthalic acid. IUPAC name will be the name of the ring, it's benzene. Then 1,2 dicarboxylic acid. Benzene 1,2 dicarboxylic acid. We have got even the 1,4 variety. So we'll just see the 1,4 variety also. That is commonly called as terephthalic acid. Like this one, COH COH. Common name is called terephthalic acid. pH is silent, it's called terephthalic acid. IUPAC name is your benzene 1,4 dicarboxylic acid. So this is as far as the nomenclature of carboxylic acid goes. Now let us see how we can prepare the carboxylic acid in the lab. Let us see the lab preparation of the carboxylic acid. So you're going to see the lab preparation of the carboxylic acid. Carboxylic acid will be making from the following compounds. We can make it from primary alcohol, obviously by oxidation. We can do it from aldehydes, again by oxidation. We'll do it from haloalkanes or alkyl halide via KCN method. We can convert the acid derivatives into carboxylic acid. Acid derivatives like acid chloride, anhydride, amides, we can make it into carboxylic acid. And then we are going to see the preparation of the benzoic acid separately. We are going to make benzoic acid separately. So let us see one by one how can you convert primary alcohol into acid, aldehyde into acid, alkyl halide into acid, acid derivatives into acid. One more we can do, we can even do it from the compounds called alkenes. Again by oxidation we can make it into carboxylic acid. So one by one let us discuss the preparation of carboxylic acid. The first one we are going to discuss is primary alcohol. Already we have discussed. Primary alcohol on oxidation will give you with a strong oxidizing agent like KMnO4. You are going to get carboxylic acid with the same number of carbon atoms. So we have primary alcohol. We are reacting with KMnO4. We can use basic medium, like we can work in KOH. Now what is going to happen? What is oxidation? Removal of hydrogen and addition of oxygen. So we'll remove 2 hydrogen and put oxygen. So we're going to get the corresponding carboxylic acid. But only problem is that we are working in basic medium. This is an acid, so this will react with the base to give you salt. So in the first place you will get a salt of a carboxylic acid. You will get COK. This is formed when an acid reacts with KOH. It is only when you acidify the medium you are going to get nothing but the carboxylic acid. So you can oxidize primary alcohol into carboxylic acid with the same number of carbon atom. Okay, like for example, somebody asks us to convert ethanol into ethanoic acid. We can do in one step. The first step would be KMnO4 working in basic medium. Second step, acidification. What will happen net result? 2H replaced by oxygen. What you're going to get is nothing but the formation of ethanoic acid. Same thing, suppose we have to convert benzyl alcohol. You know what is benzyl alcohol? Benzene with CH2OH. You have to convert into benzoic acid. So you react with KMnO4, KOH. Second is acidification. You're going to get none other than your benzoic acid. So primary alcohol on oxidation is going to give you nothing but carboxylic acid with the same number of carbon atom. Now let us see how do we convert alkene into carboxylic acid. This we have done even in 11th class. That is again oxidation of alkene under drastic condition. So we are having alkene. We are going to do oxidation of alkene under drastic condition. Under drastic condition. Drastic condition means under extreme condition, and that is when we use KMnO4 in the acidic medium. So we take an alkene. If we react with KMnO4 in the acidic medium, that would be a drastic condition. What is going to happen? The double bond will break up. You will get 2 parts. The 2 parts are going to separate out. And which part will become what? There were certain rules that we have done in 11th class, but hopefully you would have forgotten. So I'm just revising for you. If you see double bond CH2 part, if there is a CH2 group, this is the one which converts into a carboxylic acid. The CH2 becomes COH. If you see this one, CH2 becomes, the CH2 get oxidized to carbon dioxide and water. If you see CHR, if you see a CH group attached to a double bond, this will convert, CH will become nothing but COOH. You will get RCOH. And if you have got this part, double bond C having 2R group, on oxidation it will become a ketone. Let us apply these rules, then it will become more clear. So let us see one or two examples. Now suppose somebody asks you to convert propene, we have to convert it into ethanoic acid, propene into ethanoic acid. So we have propene CH3, CH, double bond CH2. We put KMnO4, H plus. What is going to happen? The double bond breaks. This part will separate out, this part will separate out. What will happen to this part, CH2 part? This will get oxidized to CO2 plus H2. What happens to the other part? You can see CH, it will become an COH, so it will become nothing but your ethanoic acid. So you are going to get ethanoic acid plus CO2 plus H2. Now suppose you have got this molecule, butene. We are oxidizing it with KMnO4 under drastic condition. That means we are using acidic medium. Double bond will break, this will separate out, this will separate out. What is going to happen? The CH, this will become nothing but COH. So what you get is nothing but two molecules of acetic acid. Now let me show you a very interesting example. It's given in NCERT. They have asked you to convert cyclohexene into hexane 1,6 dioic acid. So what is cyclohexene? Cyclohexene you can write like this for the sake of clarity. This is cyclohexene. What to do? You put KMnO4, H plus. What is going to happen? Double bond breaks. This is CH, this will become COH. This is CH, this will become COH. So what we get is nothing but COH and COH. This is nothing but the ring has broken. It's a straight chain compound. It is hexane 1,6 diacid. So alkene on oxidation under drastic condition will give you nothing but the formation of carboxylic acid. So we have done it from primary alcohol by oxidation. We have done it from alkene. It was again by oxidation. Now we are going to discuss the third method, that is from aldehyde. Again, aldehyde on oxidation gives you acid with the same number of carbon atom. So we have an aldehyde. We can use oxidizing agent, the strong one, KMnO4, in the acidic medium. For the sake of uniformity, the bond will break, CH bond will break, and the O will add up. You will get nothing but the corresponding carboxylic acid with the same number of carbon atom. Let us see the application. Suppose they ask you to convert propanal. I want to make propanoic acid. Not a problem. One step. We put KMnO4. We put H plus. Propanal will get oxidized to nothing but your propanoic acid. So aldehyde on oxidation again gives you nothing but the corresponding carboxylic acid. Now let us discuss from next compound, that is from the fourth one, that is from alkyl halides. We have got two methods of converting an alkyl halide into carboxylic acid. The first one we can do is by using the KCN method. So what we can do, we can take Rx, react with KCN. What is going to happen? The X will be replaced by CN, nucleophilic substitution reaction, and you do know if you do its complete hydrolysis, dilute HCl, the CN group will become nothing but COOH. It's a step-up reaction. Suppose you have to convert ethane into propanoic acid. Ethane has to be converted into propanoic acid. So what you do? You take ethane, put a halogen, do its chlorination in the presence of sunlight. H is replaced by Cl. Put KCN, Cl replaced by Cn. And when you put dilute HCl, the CN group will undergo hydrolysis and you're going to get the formation of propanoic acid with one carbon. Let's see one more example. Like for example, we need to convert benzyl chloride into, let's say, phenyl ethanoic acid. You want to convert benzyl chloride into phenyl ethanoic acid. Now you know what is benzyl chloride? It is benzene with CH2Cl. So reacted with KCN. When you react with KCN, the Cl is replaced by Cn. And how to convert Cn into acid? Put dilute HCl. The Cn group will get hydrolyzed and you get nothing but the formation of the carboxylic acid. So this is one of the method of converting alkyl halide into the carboxylic acid. There is one more method of converting alkyl halide into carboxylic acid, and again it is a step-up reaction. It is by a Grignard reagent. So second method of converting alkyl halide into carboxylic acid. What we do? We start with alkyl halide. We put Mg, dry ether. You know what is going to happen when you react with Mg in the presence of dry ether? Magnesium is going to add up over here. You get a useful compound RMgX, that is a Grignard reagent. Then you react it with carbon dioxide. This will undergo nucleophilic addition reaction with carbon dioxide. Carbon dioxide is going to add up over here. You will get RCO2MgX. Then you hydrolyze it with water, H2. You will get nothing but the formation of carboxylic acid. Let us see the preparation of, let's say, benzene into benzoic acid by this method. Let us convert benzene into benzoic acid by this method. Let us convert benzene into benzoic acid by this method. So what we can do? We can take benzene, we can do its chlorination, we can do Cl2, FeCl3, we get chlorobenzene. Convert into a Grignard reagent. You know how to convert into a Grignard reagent. We put Mg, dry ether. When you put Mg dry ether, what you're going to get is benzene with MgCl. And then you're going to put carbon dioxide and water. You're going to get the formation of the benzoic acid. So this is another method of converting the halogen containing compound into carboxylic acid. Both of them are nothing but they are the step up reaction. The carbon atom increases. Now let us see the second last method of making carboxylic acid, that is by using the acid derivatives. Let us see how do we convert acid derivatives into the carboxylic acid. Acid derivatives means your acid chloride, your acid amides. Acid amide is RCONH2. You can have an ester, sweet smelling compound called ester, or you can go for acid anhydride. Any of the compound you can use. For all of them, what you do, simply add water or do a reaction called hydrolysis. React with water, they will hydrolyze and you will get the formation of the carboxylic acid. So when you put acid chloride, you put water, Cl is replaced by OH, you get carboxylic acid, of course, plus HCl. NH2 group is replaced by OH, you get carboxylic acid plus ammonia. Ester OR is replaced by OH, you get a carboxylic acid plus alcohol. And if you take your acid anhydride, you're going to get the formation of corresponding carboxylic acid, 2 molecules of carboxylic acid. So all acid derivatives on hydrolysis is going to give you corresponding carboxylic acid. This is how we can prepare carboxylic acid. Now let us see the last method of preparation. Let us see the special preparation of the benzoic acid. Let us see the preparation of benzoic acid. What you can do, you can make it from any alkylated compound. You can use any benzene alkylated compound, R group on the benzene, no matter how many carbon atoms are there. If you oxidize it with KMnO4 in the basic medium, no matter how many carbon atoms are over here, the bond will break and you will get the potassium salt of the benzoic acid. You will get COK. It is only when you acidify you are going to get nothing but the benzoic acid. Let me make myself more clear. Suppose we have got this compound, benzene. We have got a group CH2, CH2, CH3 like this. We are oxidizing with KMnO4 in the basic medium. What is going to happen? The bond is going to break from here. So the molecule is going to break up into two parts. This part alone, this part alone. This will become benzoic acid. You will get benzene. Since you are working in basic medium, you will get a potassium salt, COK. This part will break, this will become COK. The other part will also become an acid with 2 carbon because this is cutting it off. You are going to get CH3, COK. And it is only when you acidify them, you are going to get the benzoic acid. So any amount of carbon atom which they are present on the benzene ring, the bond breaks after the benzylic carbon. This part will become benzoic acid and the rest part will also convert into an acid with the same number of carbon atom. Even if you have an aromatic ketone, let's say you have got an acetophenone, benzene with COCH3. What is this compound called? This is called acetophenone. If you oxidize it with KMnO4, H plus, or you can use basic medium, not an issue, or you can use an acidic medium over here. You're going to get the formation of, this is going to break like this. This will become nothing but benzoic acid. 1 carbon, this will get oxidized to 1 carbon acid, that is formic acid. So you can take an aromatic ketone, you take an alkylated benzene, you're going to get benzoic acid. So any R group which is there on the benzene ring gets oxidized to nothing but the benzoic acid. Let me make myself more clear. Suppose we have a benzene with the 3 R groups. We have an R group over here, we have an R group over here, we have an R group over here. We oxidize it, KMnO4 in the basic medium. All the 3 R group will get oxidized to COOH. So you will have a COH group over here. You will have a COH group over here. Any alkyl group attached to the benzene ring on oxidation will, and of course you are going to get a salt first of all, because you are working in the basic medium. Acid will react with the base immediately to form salt. It is only when you put an H plus, it will give you the corresponding carboxylic acid. Now in this thing, you should know one thing you should keep in mind, that suppose you have got this type of compound where benzylic carbon doesn't have a hydrogen. You know what is a benzylic carbon attached directly to the benzene ring? So in this compound you can see the benzylic carbon doesn't have a hydrogen. So in this case, if you oxidize, nothing is going to happen. No reaction will be there. So for this reaction to happen, you should have a hydrogen on the benzylic carbon. If the benzylic carbon doesn't have a hydrogen, this particular oxidation reaction will not happen. Please keep this in mind. So we've done all the preparation of the carboxylic acid. We have done it from alcohol, we have done it from alkenes, we have done it from alkyl halides, we have done from acid derivatives, and we have seen the preparation of the benzoic acid also. Lastly, let's do one question. Let's convert benzene into benzoic acid. Though we discussed this by a different method, by a chlorination, you can go by this method also. You can take benzene, subject to Friedel-Crafts alkylation. You can put any R group. You can put CH3, you can put C2H5, your wish. So benzene will get attached to the R group. Put in this KMnO4 in the basic medium, KOH. You know what happens? You get cook. The R group will become cook, COK. And when you acidify, you're going to get benzoic acid. Summary of the story is that R group on benzene becomes cook on oxidation with KMnO4 in the basic medium. So this is all about nothing but the preparation of the carboxylic acid. We can discuss today the physical properties of carboxylic acid also. we'll be discussing two property, water solubility and the boiling point. So let us discuss physical property of the carboxylic acid. Physical properties of carboxylic acid. So first of all, let us see the property that is water solubility. Water solubility. Now carboxylic acid up to 4 carbon, that is methanoic acid, ethanoic acid, propanoic acid, butanoic acid, they readily dissolve in water. They readily dissolve in water. You know why they readily dissolve in water? Because they are attracted by the water due to the formation of hydrogen bonding. They can form hydrogen bonding with water. So that is why they are soluble in water. It has been happening even in alcohol and so many compounds, hydrogen bonding. This is the edge bonding between carboxylic acid and the water. So carboxylic acid up to 4 carbon, they readily mix with water. They readily dissolve in water due to the formation of hydrogen bonding. But you know what happens is with the increase in the number of carbon atom, with the increase in the number of carbon atom, what happens is water solubility decreases. Water solubility decreases. You may be knowing the reason as the hydrophobic part, that is the hydrocarbon part, hydrophobic part, that is our part, becomes dominating, becomes bigger in size. So it starts dominating. So that's why the water solubility is going to decrease. But up to 4 carbon, they will readily mix with water. Now let us discuss the boiling point of carboxylic acid. Boiling point, you know, depends on intermolecular force of attraction. They depend on intermolecular force of attraction. So let me tell you, carboxylic acid has a very high boiling point, even higher than that of alcohols. It is even higher than that of alcohols. Carboxylic acid have a very high boiling point because they form extensive intermolecular. Extensive means बहुत ज़्यादा. Extensive intermolecular hydrogen bonding. Extensive intermolecular hydrogen bonding. You can say like this. This is one carboxylic acid. This molecule can form hydrogen bonding with other acid molecule like this. It can form with other molecule, other molecule, other molecule. So one molecule can form hydrogen bonding with so many other carboxylic acid molecules. So overall, the hydrogen bonding is very, very strong. Even alcohol form hydrogen bonding, intermolecular hydrogen bonding, but in acid, the intermolecular hydrogen bonding is very, very extensive. One molecule can form hydrogen bonding with 4 other carboxylic acid molecule, thereby they are forming very, very high extensive hydrogen bonding. In the liquid state, the hydrogen bonding is so strong that if you vaporize carboxylic acid, even in the vapor state, if you see the vapor state, the carboxylic acid molecules, they are not able to separate out. In the vapor state, the carboxylic acid molecule, they exist as a dimer. Dimer means 2 molecules are going to be in association to form a single entity. Even in the gaseous state, they are not able to separate out completely. The hydrogen bonding was so much strong in the liquid state that even in the vapor state, when they vaporize or they go in the gaseous state, where the intermolecular force of attraction has to be negligible, still they exist in the form of a dimer. They are not able to separate out completely, suggesting that in the liquid they were having very, very highly extensive hydrogen bond. So if I tell you the overall order, the compounds that we have discussed so far, if you see the order of boiling point, till now what we have discussed was the carboxylic acid have very high boiling point. Then comes your alcohols, then comes your amines, then comes your ketones, then comes your aldehydes, then comes your ethers, then comes your alkyl halide. These are just comparing the boiling point of all the compounds we have done so far. followed by nothing but the alkanes. In carboxylic acid, the intermolecular hydrogen bonding is intermolecular force of attraction is the hydrogen bonding. In alcohol also it is the hydrogen bonding, but I have just told you that it is more extensive in the case of carboxylic acid. Amines also hydrogen bonding but weaker. Ketone dipole weaker. Aldehyde dipole weaker than ketone. Ether again dipole. Alkyl halide, you know, van der Waals force. Again this is van der Waals force. So this is the net order of boiling point, comparison of the boiling point of all the compounds we have discussed so far. So in the next class we'll be discussing some of the chemical properties of the carboxylic acid. Okay, have a nice day. Please take care.